Next, let's talk about what happens when we change b. Remember, b is inside of the function. And so if we have sine of b of x, when b equals 1, this is just sine of x, and once again, we've got an ordinary sine graph. This time, as we increase b, we can see that the function gets squished in horizontally. We have more oscillations in the same period of time. Similarly, if we decrease the value of b, so it's smaller than 1, the function will stretch out horizontally. What do you think would happen when b becomes negative? Sure enough, we will flip over the y-axis this time. This means that the value of b affects the period of the sinusoidal graph, which is how often the graph repeats itself. The formula is period, p, equals 2 pi divided by b. For example, if b equals 1, that means that the period is 2 pi over 1, which is 2 pi. That tells us that the graph repeats itself every 2 pi units. On the other hand, if b equals 2, that means the period is 2 pi over 2, which is pi, and that means the graph does one complete up and down cycle returning to where it started every pi units. That is, it oscillates twice as quickly. So if we know the value of b, we can use it to calculate the value of p. Again, using the formula p equals 2 pi over b. In this case, sine of 4x, that tells us b equals 4. And therefore our period is 2 pi over 4, which is pi over 2. The graph would do one complete cycle every pi over 2 units. This applies for cosine as well. In this case, we have b equals 1/6. It's a fraction. That's okay. Our period is 2 pi divided by 1/6. That's the same thing as 2 pi times 6, or 12 pi. This time the graph would be stretched out to the point where it only oscillates once every 12 pi units. It's worth noting we can also rearrange this equation to get b equals 2 pi over p, so that if we know the period, we can calculate what value of b gets us there.